Hey guys, welcome to day 2 of the CSES problem set. Without further ado, let's just jump straight into solving problems. Increasing array. So we're given an array of n integers. You want to modify the array so that it is increasing every element. So given an array of n integers, you want to modify the array so that it is increasing, i.e. every element is at least as large as the previous element. So I'm thinking about sorting right now. On each move, you may increase the value of any element by 1. What is the minimum number of moves required? Okay, so moves. It wants moves now, so that is making it a little bit more difficult. So our input is n equals int input. That's the size of the array, and then an array a equals what would they call it, x here, list map int input dot split. Okay. Now first line contains an integer n, the size of the array. Second line. Okay. Maximum number of moves. So on each move, you may increase the value of any element by 1. What is the minimum number of moves required? So output is 5 moves. So at least as large. So we can match these, right? So this to 3, that's 1 move. And then this to 5, that is 2, 3, 4, 5. That's 4 moves. So 1 move. Okay, I see. So we can iterate through for I in range n. We can do prev equals x1 or xo, and then we can do from 1 to n. And then if xi is less than x or then prev we can do we even need prev? We can just do xi minus 1. Xi minus 1. Just remove prev. We can track variable moves. So 0, and then moves equals or plus equals. It would be prev minus xi. So xi minus 1 minus xi. Print moves. Right. There we go. Yeah, just 3 minus 2, then 5 minus 1. Okay. There's no submit button for this one, I guess. I think I have to manually submit it. Browse, programming, CSES, increasing array. Submit. Wrong answer. correct output is this. Okay, so what's going on? I is 1, prev is this number, so moves would be let's reread the task to see if I'm missing anything. At least as large as the previous element, you may increase the value. Okay, so moves would be this minus this. And then we need to set xi to be equal to xi minus 1. There we go. That's what we were missing. Just check this case real quick. Browse, increasing array. There we go. Accept it. Next question, permutations. A permutation of integers 1, 2 to n is called beautiful if there's no adjacent elements whose difference is 1. What does that mean? Given n, construct a beautiful permutation if such permutation exists. If the only input is n, okay. A beautiful permutation of integers 1, 2 to n. If there are several solutions, you may print any of them. If there are no solutions, print no solution. So inputs 5. A permutation of integers called beautiful if there's no adjacent elements whose difference is 1. So 5, 3. Alright, no. 5, 3 doesn't work. 5, 3 does. Okay. What's the ordering? So if we're given this, then it's 1, 2, 3, 4, 5. And then our ordering. Wait, let's try with minimal case first. Minimal case given 1, then it's just 1, no adjacent. If we're given 2, it's 1, 2, then this is impossible. Three, 1, 2, 3. We can do. No, this is impossible. 4, 1, 2, 3, 4. Do 4, 2. This is impossible. 5, 4, 5. 5. We can do 4, 2, 5, 3, 1. 4, 2, 5, 3, 1. So on 6, I can do 5, 3, 6, 4. No, we can't do 6, 4 because then we'd rather do 2, 1. So it's 5, 3, 4, 2, 1, 6, 7. I don't see a pattern. That's the issue. Do 6, 4, 5, 3, 6, 4, 5, 3, 2, 7, 1. Is there a better pattern? Like something like. This is the first instance where it works. So maybe like 1, 3, 5, 2, 4. That works. For 6, we can do 1, 3, 5, 2, 4, 6. 1, 3, 5, 7, 2, 4. Okay, we might be onto something where we do like odds evens. This reminds me of a problem, of a code forces problem. So 1, just 1, 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 we do odds evens, 6, I think odds evens is the strategy. So I just don't know. I guess case 1 counts. So what cases don't work? 2, 3, 4. Do any other number work? 6, 7, 8. 8 we can odds evens. 1, 3, 5, 7, 2, 4, 6, 8. So it's just 2, 3, and 4 that don't work. If n equals 2 or 3 or n equals 3 or n equals 4, print no solution. Else, equals an array. Let me think, how do we do this? We want to print all the odds first and then all the evens next. We can do like for I in range from 1 to n start, stop, step to print dot append I, and then for I in range from 2. Yeah, okay. So Well, I guess this wouldn't work because there's multiple kinds of solutions. Alright, so let's just do this and see what we get. 5. Oh. Print. To print. Oh, I should probably keep this in the else statement. And we can define to print in the else statement as well, because then we use less memory. It doesn't really matter. 5. 1, 3, 2, 4. That's not right. We're missing a number. 1, 3. N plus 1. So it stops at N. N plus 1. 1, 3, 5, 2, 4. Okay. If we do 6, 1, 3, 5, 2, 4, 6. Perfect. And if I do something like 3, no solution. Yes. Wrong answer. One case of wrong answer. So number 4. Inputs 4. There is a solution for input 4? 2, 4, 1, 3. Although look at this. 2, 4, 1, 3, 5, 2, 4, 6, 1, 2, 5. They're doing even first and then odd. This specifically for case 4, because it doesn't matter afterwards, right? Case 4 we can't do 1, 3, 2, 4 because these touch, so we do 2, 4, 1, 3. That's smart. So we do evens first and then odds. Basically, like this. Date modified. Wrong answer on 4 still. Hello? Run 4. Oh, it's because I'm still including this check here, which shouldn't exist. 2, 4, 1, 3, and then we do 5. 2, 4, 1, 2, 5. Okay, yeah. Do, 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 do. Do, 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 do. There we go, accepted. Analysis. Case 1 is simple. There's no solutions for 2 and 3. If n is greater than or equal to 4, there's always a solution. We got that far. The following code uses a construction that also works for some other constructions require n equals 4 is handled as a special case. Yes, so basically what they do is the same thing. Well, they add a special case for n equals 1 that's not needed, as we show. And 2 and 3 return no solution, and then int I n divided by 2. I is greater than or equal to 1, I minus for int I equals n divided by 2. While I is greater than equal to 1, I minus print I space I plus n divided by 2. Okay, good for you. Let's do the next problem. Number spiral. A spiral is an infinite grid whose upper left square has number 1. Here are the first 5 layers of the spiral. Your task is to find out the number in row Y in column X. Okay. Okay. The first input line contains integer t. Okay. After this, there are t lines each containing integers y and x. So for blank in range t, y, x equals map int input dot split. Your task is to find out the number in row Y, column X. Okay, so a number spiral is an infinite grid whose upper left square is 1. Here are the first 5 letters, so it goes 1, 2, 3, 4, 5, 6. 1 plus 3 plus 1 plus 11. So 1, 4, 5, 16, 17. 1, 4, 5, 16, 17. This is 3, 1, 11, 1. What's the next number? 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. It would be 36, which is it's 19. Right, so what's the pattern? And the next one would be 1, so this is 37, 1. Right, so what's the pattern? 3, 1, 1, 2, 3. It's this number. It's plus 3, 5, 7, 9. Right? 3, 5, 1, 2, 3, 4, 5, 6, 7. This is 5, 9. 3, 5, 7, 9. So 3 plus 3, 5 plus 7. And then 3, 5 plus 7, 9 plus 11. This is 12. Wait a minute. Okay, so this is difficult. This is difficult indeed. So I kind of see the pattern where each line is 3, 5, 7, 9. Now, it would really help knowing the formula for incrementation for the left side, because then we can just count for y. Okay, what is y? It's yx, right? Containing integers y and x. So 2, 3. Output's 8. So y is the row 2, column 3. Okay. Yeah, so as long as we can find a formula for y, then we can just count x. So the formula looks like 1, okay, well, it's 1, 4, 5, 16, 17. 1, 4, 5, 16, 17, 36, 37. Alright, let's double check. 17, 5, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Yeah, okay. 3, 1, 9, 11, 1, 19, 1. So 1 plus 3 plus 1 plus 5 plus 7 minus 1, because we're already counting this. So 1 plus 3 plus 1 plus 5 plus 7 minus 1 plus 1 plus 9 plus 11 minus 1 plus 1. Alright, this is 20 minus 1 is 19. Okay, so this is the pattern. It's every two numbers we have a plus 1. It's 1, 4 plus 1. 16, 17. Wait. No? Plus 3 plus 1. It's every other number. We have a plus 1. Odd. So on evens we have plus 1. So if y is even, wait. What's the formula? So by default, it's 1. So we have something plus 1. And then it's 3, 5, 7, 9, 11. Even is plus 3. So if y is 3, corresponding number is 5. If y is 4, corresponding number is 16. 5. 15 plus 1. It's 5, 6, 7. 3, 5. If it's 3. It's 3, we just have this. If it's 4, we have these plus 1. If it's 5, we have these plus 2. If it's 6, we have all of these. So, okay, so case y equals 1. Or, okay, 2. 1, 2. 1, 2, 3. So, yeah, where indices 0 doesn't exist, we start at indices 1. Case y equals 1. Row. In case y equals 1, then row equals 1. Case y. What's going on? Case y equals 2, 3. Three, 5, 7, 9, 11. Let's just define odd. Get odd. Def get odd. I. Return. It's 1, 3. Technically, it's 1, 3, 5, 7, 11. We return if I want the third index. 3 times 2. I times 2 minus 1. So if we want the first index, 1 times 2 is 2 minus 1. Second index for fourth index, okay, yeah. So we have this getOdd function, and then I'm trying to make the equation out of this, but I'm struggling. If it's even, then we add 1. Say 0. So if it's even, add 1. If y is so if y mod 2 equals 0, then we need to track a variable. We need to track a variable called like max, called row. I don't even know what to call this. Just call it row. Row equals 0. Then row plus equals 1. Else, if it's odd, get odd, row plus equals get odd I plus get odd I plus 1. Now where do we get this I? For I in range Y. If I mod 2 equals 0, what does this give me? One. That looks correct. 1, 5. That's not right. Y? Y is 2, so start at 1. Then we go to Y. 4. Y. Okay, given this image, if Y equals 1, row should be 1. So Y, row. Y is 2, 4, 3, 5, 4, 16, 5, 17. Okay. So for I in range y, y is 1, 0. Get odd 1 plus 3. So we should start at 0. Y. Start row at 1, and then we start this out. If y is 1, then nothing will happen. Right, and then if we do 2, if we do, we're here all of a sudden, that's not right. Case 1, 1. Case 2 is plus 3. So if I is equals to 2, row plus equals get odd I. This is a special case because this is the only time we get odd ones. Now else we follow this pattern. On 3, it's odd. Odd, so we get odd. Even, so we add 1. Odd, so we get odd. Even, so we add 1. Odd, so we get odd. So it's even, we add 1. So if it's 3, so it's 1. We skip 1 because by default it's 1. At 2, we get odd. At 3, we it's like this. One. At 2, we get 2. That's not right. At 2, we get odd I. I would be equal to 2. So we would do 2 times 2 minus 1, which is 3. Why are we getting 2? We never entered here. Print I. Y is set to 2. So we do y plus 1 after all. Y is 1. If I is 1, row is 1. Why don't we just start at 2? Because we handle case 1 already. I is 2. That still gives us 1. And then 1, 2, 1 gives us 4. And then 3 gives us 5. And then 4 gives us 21. That's not right. It should give us 16. I is 4. So we get 8 minus 1 is 7. Plus 9. Wait, hold on. I is 4. So we do get odd 4 and 5, which is 8 minus 1 is 7. 10 minus 1 9, which is 16. That's not right. Because row is 5. We're at 9. Four is 16. We're at 5. This is a gap of 11. So we need I minus 1. We need 5. This is 1, 2, 3. We need 3 and 4 minus 1. We're looking for here. We're at 4. Is this it? 16, and then just do like, give us 5 cases. Okay, so this is our equation. Now, I don't really like having to define this here, but it makes it simpler, so we'll keep it for now. Now, plus x, because it would be, if we find 4 and x is 3, we would do 4 plus 3. Wait, that's not right either. Because x's have their own pattern. Oh my gosh. All this and we only find the y pattern. Yeah. So what's the x pattern? It's like the opposite. It's +1 plus 7 plus 1 plus 15. Eight minus 1. Holy shit, this hurts my head. So we do the same for call. This question is the end of me. How long has it been? An hour? Jesus. By default, it's 1. If I equals 2, so if it's even, let's see, it's 1, 1, 2, 2, 3, 9, 4, 10, 5, 25. So, default case, when it's 2, we add 1. It's 3, we add get odd. Two, get odd 3. Then we add 1. Then we add get odd 4, or minus 1, plus get odd 5, minus 1. So column equals 1. I is equal to 2. There's no special cases, right? So if I mod 2 is equal to 1, call, or if I mod 2, so if it's even, then call else, call plus equals 1. Print out call for now. One. Oh, oops. 4. Oh. Change this to X. Run this. 1, 4. That's not right. Call 2 is equal to 2. I should get a plus 1. Range 2. Print I I I is 2. So it should be call plus 1. 2, 9, 10, 25. Oh my gosh, I'm doing it. Now at the end it should just be roll plus call. Just clear. Fail. Show over. Because I'm printing. Fail. Show over. What am I messing up on? I got 13. I print row and call. 3, 2, 3. Row 4, column 9. Yes. 1, 1. It's 1. Yeah. Then 4, 2. 16, 2. Okay, I find all the right rows and columns, but that's not exactly what I need, is it? I feel like I'm solving for the wrong thing the whole time now. Add one, subtract one. One. Bro, this question's hard. Given the right column, what do I do for the rows? I can add +1 +3. Are these the same? Yeah, these are the same amount. +1 +3 +1 +3 +1. So this will be +1 +3 forever. This will be +1. This will be +11 +11 or +11 +9 +7 +11 9 7 1 -1. What? This is 1 3 5 7. I'm a little bit stuck. Hmm. Hmm. One, 10, 25. 5, 4, 5, 16. 36, 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. It's 3, 11, 19, 1. I need some water. Be right back. Okay. What the hell is this question? Here's also something interesting. It's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. And the next one here is 36, which is 6 squared. So the squares alternate. I don't know if that's helpful at all. It's just, here's what I don't get. It's like if I find the number on the y-axis, if I find the y we need, so for example in case 2, 3, we find this, how does that correlate to the x-axis? Because, okay, for a more obvious one, like say we find this, and x is like this, so say we have case 4, 3, right? It's here, we just find this and we subtract 3 plus 1. and we find it. But if it was 4, 5, and we're here, then we can't just, we have this number. I guess we can do 25 minus 4 plus 1, 16. Wait a minute. Maybe these squares can help us. 25, so if we have case 2, 3, 2, 3, that'd be here. Our other case was here. So we can do 9 minus 2 plus 1. 4, 5 is 25 minus 4 plus 1. If we do a 3, 2, then it's then what? Nine minus, it's 9 minus 3, which is 9 minus 2 minus 1. That's not it. So what if I do 4, 3? What's the pattern to this? No, not 4, 3. 5, 2. 6, 4, 5. I don't know, maybe I'm cooking too much. Clean this up a little bit. We're given this, and our special cases are 1, 4, 9, 25, 16. These are all our squared digits. 2, 3 here is 9 minus 2 plus 1. Okay, say we have a case like 4, 2, 16 minus 2 plus 1. In case 3 or 2, 3, 9 minus 2 plus 1. So there's this case where it's max yx minus min yx plus 1. So if it's 5, 3, 5, 3 should be 19, which would be or it'd be squared. 25 minus 3 plus 1, which is 23. That's not right. 5, 3 should be 19. But if it was 5, if it was 2, 4 would be 16 minus 2 plus 1. 2, 4 should be 11. This is 4, 15. This is 2, 4. This is 4, 2. That's not right. Two squared minus 1. If I did 5, 3, 25 minus 9 minus 1, 16, 15, 5, 3. That's not it. 4, 2. 16 minus 2 plus 1. Five, 3. 2, 4 was a weird case. 16. Okay. 2, 4. 16, 9. 16, 9. 10, 11. 2, 9, 10, 11. Wait a minute. 5, 3. For 16. 17, 18, 9. Oh, wait a minute. So there are cases where it's max y x minus 1 squared plus min yx. So these are the two cases. Everything falls under one of these two equations. The problem is, when do you use these equations? If okay, so these are the cases. These are case 2 problems. These are case 1 problems. What do these have in common? What do these have in common? So if where's the max? 3, 4, 4, 5. The max. This is a type 1. We go here. This is a type 2. This goes here. do you use this? 2, 3. 2, 3. 4, 2. 2, 4. 5, 3. It goes like this, 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 wait, this, this, this. 2, 3. 4, 2. Wait, hold on. This is going this way. This is going this way. This is going this way. Does this have anything to do with it? The direction is up, up. So what is this one? This is case 3, 2, 6. 9 minus 2 plus 1 is 9, 8, 7, 8. That's not it. So 9, so 3 minus 1 is 2, 4 plus 2, 6. Falls under case 2. So 3, 2 falls under case 2. 4, 2, 4, or 5. This case 2 is like this. So if it's going okay, so let's try 3, 5 then. 25 minus 3 is a case 1. 3, 5 is a case 1. Why is this the case? If it's going up, it's case 1, is that it? Up. If it's going left, it's case 2. If it's going right, it's case 2. If it's going left, it's case 1. So it looks like this way. Is this it? What can I keep? Let's keep this and this. And then let's comment all this out. If How do we determine the direction of the arrow? Goes left. Down. I don't get it. Because we have left and up. And we have down and right. But these mean different things. This is case 2, this is case 1. And this is case 1, this is case 2. So it's really a case of -1 and plus. Squared -1 and plus. Or squared and minus. Two, 3. 3, 2. 2, 3, 3, 2. 3, 2 is -1 and plus. So, okay, so we'll have a max. Max xy, max yx, max square. What do you call it? Max input max. This is max y x, right? Input max 3, 2. 2, 3. Or 4, 2. 2, 4. 4, 2, 2, 4. 4, 2. Input max is 4. to 4. Input max is 4. Why is this so complicated? Okay, what am I stuck on? We're stuck on how to know which equation to use. We know which equation to use by the direction of the arrow. How do we find the direction of the arrow? So it points up and to the left on this way, this is down, technically. So we basically have if case 1 then in print input max squared minus min. I should probably calculate an input min. Minus input min plus 1 else print what's going on? Why is this gray? Print input max minus 1 squared. Oh no, because it never reaches because it's true. Okay, yeah, whatever. We'll change that later. Plus input min. These are our two equations. We just need to. The last thing to figure out really is this case. How do I figure out this case? When does the arrows point up? It points up at 9:25. When does the arrows point left, 4, 16. What does that mean? Given our input max, so take case 4, 2. It's on an arrow that points left. So we are checking, we're basically checking (16) and 4, 2. 2, 4. Max is 16. 5, 3. Max is 25. 3, 2. Max is 9. Okay, so what the max does is it tells us the orientation of the arrows. It tells us whether we are on a or B arrow. If it's even, so if our max is even, we are on a B arrow. If our max is odd, we are on an A arrow. So if input max 2 or modulus 2 is equal to 0, then we are on a B. If it's even, we are on a B arrow. If it's odd, we're on an A arrow. Let's just rename these. A, B. So now, if input max if input max we're on an A arrow, which means down is case 2, to the left is case 1, to the left down is case 2. So if input max I'm looking at case 4.2. Our input max is even. So we are on a case A arrow. Now, how do we split these here? We're 2. Case 4, 2. It's even. Because if our max was 5, the only way we could, 4.2. If our max was 5, then we'd go on the next line. Now, given the max, so now we need to check our y value. Our y value to see if we are one of these guys or one of these guys. What do we do at case 13, actually? 13 is on both arrows. This is 1, 2, 4, 4. What do we do on 4, 4? Does it matter what we do? I don't think it matters what we did. 16 minus 4 plus 1 is 12, 13. And this one is 4, so 3 is 9 plus 4 equals 13. Yeah, so case 13, it doesn't matter what we do. So we're really just looking at the y value. If y is equal to max, so our max is 4. If y is equal to max, then we do case 1. So if y is equal to input max, then we do case 1. This is case 1. Else, we do case 2. Now, if we're odd, which means we're on one of these arrows, we check the opposite, right? If x is equal to input max, then we do case 1. Else we do case 2. Okay, that worked. Bro, this question was destructive. What time is it? This video is 2 hours long. Jesus. Let's see if this works. If it doesn't work, I'm gonna go crazy. 2 test cases, that's it. We got it? Well, we got it. Analysis. Following function calculates the number in row y column x. A useful observation is that the spiral consists of layers. We calculate the current layer m equals max. Okay, we did that. There are m minus 1 squared numbers in the previous layers. Yes, input max minus 1. And m is max. And then we calculate the numbers in the current layer. There are two cases. If m is even, then we go from upper right to lower left. So it's down, yeah, and if m is odd, we go left, up. Okay, yeah. Yeah, like, that's basically what we have. Jeez, this question was a struggle. It was a mental puzzle. I guess what was the hardest part of this question? The hardest part was recognizing that we could use these squares. Like, I didn't even recognize like the squares at first. I tried to create a formula. I did end up successfully creating a formula for finding the row and column given y and r, but that's not what the question wanted me to do. I wonder if I can, like, given a row, no, because column really does matter. If I was given the row, no, it does matter. This solve is much more better than what I had before, because then I would need a different calculation for column. Or I guess if I found the row and column, I could do some if statement check to determine. But then I could, yeah, that's could be basically simplified to max and min, right? Like, my earlier approach was just pure simulation. Now the hard part was recognizing what conditions, when to choose which equation. Was recognizing that down in left was equation 2 and up and, or down and right is equation 2, up and left is equation 1. This question was hard. This question was actually hard. Like, this wasn't like a cyclic merging kind of hard. This was like a thinking kind of hard. I'm glad I could work it out, but like, this was actually a hard problem. I kind of want to ask around and see if my other buddies could figure this out, or at least what their intuition is for this. Statistics, success rate, attempts. Okay. Alright. The video's dragged on for long enough. If you like this video, be sure to like and subscribe. I'll see y'all guys tomorrow.